Algebra 1, Unit 3, Introduction to Functions, the study guide. All right, number 1, is it a function? Yes or no, and then explain. All right, so when you have a graph, the way you can determine if it's a function or not is using what's called the vertical line test, which means draw as many vertical lines as you can. If each line that you draw only intersects the graph once, then it's automatically considered a function, which means it passes the vertical line test. If you can draw even one vertical line that crosses the graph more than once, that means it's not a function. It fails the vertical line test. All right, so for number 1, if you drew a vertical line here, it looks like it passes. If you drew one here, it looks like it passes. Even over here, looks like it passes. But if you were to draw, let's say, for example, this line right here, it intersects it 1, 2, 3 times, which tells me that it's not a function. And then in your explanation, you could say the graph fails the vertical line test. Okay, I'll call it the VLT for short. That stands for vertical line test. All right, number 2, is it a function? Yes or no? Again, explain. For this one, we're looking at the x values. Notice there's repetition here. Okay, so that's something we want to look at. And then the issue here is that the input 2 goes to 9, but then it also goes to 11. So if you guys think back to the hot dog problem that we did in class, if we were talking about hot dogs, right, as our input, we don't know if it's going to cost us $9 or if it's going to cost us $11. So one of the first issues is that the x value 2 repeats, but the bigger issue is the fact that the input 2 has 2 different outputs. Okay, so this is not a function. And we can put down the x value 2 repeats and has different outputs. Okay. Number 3, we have the equation y equals negative 3x plus 1. We're told to identify the slope in the y-intercept and then graph it. So first thing you want to figure out here is that this equation is in y equals mx plus b. Okay. B is our y-intercept, so that's positive 1. So on the y-axis, it's called the y-intercept because it intersects the y-axis. Positive 1 would be right here. And then m is our slope. We just want the number in front, the coefficient. Okay, so our slope is negative 3, which is okay, but we want it as a fraction so that we can determine what the number on top tells us to go, where the number on the bottom tells us to go. So we can always make an integer like that a fraction by putting it over 1. The negative 3 on the top tells me to go down. The positive 1 on the denominator tells me to go to the right. So from my y-intercept, I'm going to go down 1, 2, 3, and then to the right 1. And I'm going to keep following that pattern. Down 1, 2, 3, to the right 1. Drops me right here. There's no more space going to the right, so I'm going to go to the left. Starting back at the y-intercept 1, instead of going down 3, I'm going to go up 3. Instead of going to the right, I'm going to go left 1. Okay. These are equations, so you don't need to worry about what kind of line or about shading. That's all we got to do for that one. The next equation, 3x minus 4y is equal to 24, is in what we call standard form. So that's ax plus by equals c. For this one, you just need your x-intercept and your y-intercept, okay? This is drastically different than the one we just happened to do. So for this one, I want to know where it crosses the x-axis and then where it crosses the y-axis. Once I find those two values, I can plot them and then connect them. So to find the x-intercept, okay, which is a point that goes on the x-axis, you're going to let y equal 0. Okay, and a reminder why we do that, any point that happens to be on the x-intercept will have a y value of 0 because it's not going up or down. So we have the equation 3x minus 4y is equal to 24. If we let y equal 0, we're going to plug that in. Okay, so then negative 4 times 0 will just be 0, leaving us with 3x is equal to 24. Dividing both sides by 3, turns out x is equal to 8. Okay, so that tells me that on the x-axis, This graph will intersect it at 8. So 1, 2, 3, 4, 5, 6, 7, 8 gives me this point right here. So your x-intercept is at 8. If you want to write it as an ordered pair, x was 8, y was 0. Okay. To find the y-intercept, so where it crosses the y-axis, we're going to want to let x equal 0. And the reason we do that is because any point on the y-axis will have an x value of 0 because it's not going left to right. So same equation, 3x minus 4y is equal to 24. But now wherever I see x, I'm going to plug in a 0. 3 times 0 is 0, leaving behind a negative 4. Y is equal to 24. Divide both sides by negative 4. Turns out y is equal to a negative 6. So that tells me that my line crosses the y-axis at negative 6. So here's negative 1, negative 2, negative 3, negative 4, negative 5, negative 6 would be right there. So that's the ordered pair 0, comma, negative 6. Let me just fix that 0. And then now that we have our 2 points, you can go ahead and connect them with the line. Make sure there's arrows going in both directions to let us know that the line keeps going on forever. All right, number 5, y plus 2 is equal to 1/2 times the quantity x minus 4. This is an endpoint slope form. The formula for that is y minus y1 equals m parentheses x minus x1, where m is going to be our slope, so that's going to be 1/2. Our point will basically come from x1 comma y1. x1 looks like it's minus 4 in the formula. We take the opposite sign of that. We get the positive value 4. y1 looks like a positive 2. We take the opposite of that, which would be negative 2. So we're going to start by plotting the point for negative 2. So if we start at the origin, 1, 2, 3, 4 to the right, down 2, it gives me a point right here. And then to find the other points, we're going to want to use a slope. The positive 1 in the numerator tells me to go up 1. The positive 2 in the denominator tells me to go to the right 2. So from that point for negative 2, we're going to go up 1 to the right 2. And no more points in that direction, so follow the pattern backwards. Down 1, left 2. Down 1, left 2. Down 1, left 2. Down 1, left 2. It's just a regular equation, so we don't have to worry about what kind of line. And we don't need to worry about shading either. All right, the next equation, x is equal to 4, is not in slope form. It's not in standard form. It's not point slope form. These are a little bit different to deal with. We know it's going to cross the x-axis at 4. So here's the x-axis. Positive value 4 is right here. This is either going to be a vertical or horizontal line. It can't be horizontal because if I drew a horizontal line, it would cross the x value 4, but it would also cross all the other x values. And I need it to always stay at 4, which tells me that what we're looking at is a vertical line. Again, you don't need to worry about whether it's dashed or solid because it's an equation. And we don't need to worry about shading either. So that's just a graph right there. All right, number 7, even though it may not seem like it, is in slope-intercept form. So we have y equals mx plus b. There is no mx term in that equation, so the slope is 0. The y-intercept is going to be on negative 2. So on the y-axis, negative 2, negative 1, negative 2 would be right here. Because this line has a slope of 0, that tells me that the line must be horizontal. Okay. Now, if you had considered for a second that maybe the line was vertical, if we had drawn a vertical line, the line would cross the y-axis negative 2, but it would touch all the other y values too, which would make the equation inaccurate. By drawing a horizontal line through the y value negative 2, we ensure that y is always negative 2. All right, for number 8 says evaluate the function f of x equals 3x minus 7 when x is equal to negative 1. So just to recap what we did in class a while back, we had x, which was our input. We would plug it into the function, and what would come out is y. Okay. They're telling you x is -1, so that's what they want you to plug in. This is the function that they want you to plug it into, and they want you to figure out what that y is. Okay, so we're going to let x equal -1, and wherever we see x, we're going to plug that value in. So we have f of -1 equals 3 parentheses -1 minus 7. Okay, on the left, this notation right here is just telling me that we have a function and which x value we're plugging in. We're plugging in -1, so we're not really doing anything to the left. I have a function, I'm plugging in -1. On the right, you're just using order of operations to simplify that expression. So we'll do multiplication first. 3 times -1 is -3. Bring down the -7. Again, on the left, we have a function. What are we plugging in? -1 equals -3 minus 7 gives us a -10. Okay, this is our final answer. You could also write that as we plugged in the x value -1. What came out was the y value -10. Okay, you could write it like that as well. And that basically, you don't need to, but just so you remember, we could write this as the ordered pair x, y. We plugged in -1 for x, and what came out was -10 for y. Again, not necessary, just letting you know that it is possible to write it that way. All right, number 9, we have the function f of x equals 3x minus 2. When f of x equals 19, find the value of x. Okay, so again, we have a 3-column table. We plug in x. We know what's going to come out is y. And the function goes in the middle. Okay. They're telling us to find the value of x, which means we don't know what was plugged in. We know we had to plug it into 3x minus 2. And what came out was 19. Okay. So they sort of want us working backwards here. Now, just to recap too, y is the same thing as f of x. Okay. So if it helps you, wherever you see f of x, you can replace it with y. Okay. That's just telling you have a function, you're plugging something in, but what really is important there is what comes out. So we have y equals 3x minus 2, and we're told that y is equal to 19. So I can replace 19 with y. Or sorry, replace y with 19. And then I have an equation here where I want to solve for x. So there's no distributive property because there's no parentheses. We can't combine like terms. The next step is to add or subtract. We add 2 to both sides to get all my constants to the left. On the left, 19 plus 2 gives us 21. On the right, the 2's cancel, leaving us 3x. Step 4 is to multiply and divide. This is 3 times x. I want to undo that. So I'm going to divide both sides by 3. Turns out x is equal to 7, right? So that's what they plugged in. So you could just, your final answer could just be x is equal to 7. Just again, a little extra piece of knowledge here. That means they had given us the y value 19, and they wanted to know which x value would we need to plug into this function in order to get this y value. And the answer is 7. All right, number 10, graph the following inequality. You hear the words inequality, immediately you're looking at that inequality symbol. So very similar to y equals mx plus b. Major difference is now that you have an inequality symbol, not an equal sign. So your line will either be dash or solid, and there's going to be some shading. You want to start with your y-intercept, which is b, which is positive 3. So on the y-axis, positive 3, 0, 1, 2, 3 would be right here. Then you want to use your slope, which is the letter m. We have negative 1/4. You can toss that negative either to the top or to the bottom. I'm going to go ahead and toss it to the top, just a personal choice I'm making. The negative 1 in the numerator tells me to go down. The 4 in the denominator tells me to go to the right. So from my y-intercept of 3, I'm going to go down 1 and to the right 4. Down 1, to the right 4. No more points, and to the right. To the left, I'm going to follow the pattern backwards. So instead of going down 1, up 1. Instead of going right 4, left 4. Okay, so up 1, left 4. Okay. This right here, y is less than. The first thing the inequality symbol tells me is that we're going to want to do a dashed line. Okay. And the reason we do a dashed line, just a reminder, let's say we had something like x is less than 5, right? And I told you, what are some possible values for x? Well, if you're thinking x is less than 5, x can be 4, 3, 2, 1, and so forth. But because x has to be less than 5, x cannot be 5. So sort of the same concept here. Because y is less than everything to the right, we don't want to include it. So we do the dash line to show that. All right. This also tells us that if y is less than, here's my y-intercept 3. I want to shade everything that's less than 3. What y value is less than 3? 2, 1, 0, and everything that's negative. So that's going to be everything below the line. Okay. And obviously, when you're graphing in person, you can do a better job of shading. Okay. Two solutions. So I want two ordered pairs, two coordinates, 2 points. They're located within the shaded section, right? And there's a lot to choose from, right? So just like one example here, I could use this point right here, right? Because it's in the shaded section, also known as the solution region. That's the ordered pair 5, -3. Another point could be this one right here, right? It's located within the shaded region. That would be considered, or that would be the ordered pair -8, 2. Okay, these are possible solutions, and there's plenty to choose from. Now it says not solutions. I probably could have phrased that better. But 2 points that are not solutions. So we want points that are not in the shaded region. So like a good one would be here. Okay, so 3, 5 would not be a solution because it's not located within the shaded region. Another possibility, a little bit more complicated, but still valid. This point right here, -8, 5, would not be a solution, right? You might be thinking to yourself, but it's right on the border. It is, but the fact that the line is dashed means any point on that line would not be included. If the line had been solid, -8, 5 would have been a solution. So something to just keep in mind. All right, number 11, graph the following inequality, very similar to the one we did right before. So we have y equals mx plus b. Obviously not an equation though, we have an inequality. Starting with our y-intercept, which is represented by the letter b. Y-intercept is -2, so on the y-axis, -2 would be right here. And then we want slope represented by the letter m. Slope is a positive 2/3. The 2 in the numerator tells me to go up. The 3 in the denominator tells me to go to the right. So up 2, right 3, up 2, right 3, up 2, right 3. Okay, following the pattern backwards, instead of going up 2, we're going to go down 2. Instead of going to the right 3, left 3, down 2, left 3, down 2, left 3. Okay. Then we have the inequality symbol less than or equal to. When it has that partial equal sign to it, that tells me it's going to be a solid line. So connect the points with a solid line. Draw your arrows to let me know it goes on forever. That says y is less than or equal to. So if you look at your chart that I provided in your notes, or if you just think, all right, my y-intercept is -2. I want y values that are less than -2. What's less than -2? -3, -4, and all that's located underneath. So that would be the shaded region. Okay. We want points that are solutions. So again, several to choose from. Let's go with this one right here. That would be 8, -6. Another one would be, that's a good one too, 10, 2. And there's so many to choose from. Those are just 2 possible solutions. Some points that are not solutions. Random point over here where it's not shaded, right? So that's -8, +6. This one right here would be not a solution. That's 3, 2. Okay. Any point on the line this time would be considered a solution because the line is solid. All right, number 12 says find the slope of the line shown. To find the slope, we need exactly 2 points. This one right here, you want points that are on the line. That's super important. But you also want them to be on the corner of the grid, because at that point, you know exactly what the coordinate is. If you decide to use a point that's not on the corner, you're going to be taking a guess. And no matter how good of a guess it is, it won't give you an exact answer, because at the end of the day, you're just guessing. I think some of you guys might have chosen 1-0, but hopefully you could tell now that the blue line is a little bit above it, so it doesn't quite hit it at the corner. It looks like the next really good point will be this one right here. And again, when you're taking the test, if you feel like you're not sure if a point is exactly on the corner or not, that's something that you could very well ask. Slope is represented by the letter M, which is the change in y over the change in x. So it doesn't really matter which point you start at. I like to go from left to right. So going from left to right, I would hit this point first. So that's where I want to start. And eventually I want to end up on the other one. Okay. And when you calculate slope, you're basically calculating the directions from one location to the next. So changing y, you can either go up or down. We're going to have to go down 1, 2, 3, 4, 5. And because I went down, it's going to be a -5. And then you have to go to the right, 1, 2. And because I went to the right, it's a +2. -5 over 2 can't be simplified any further, so we could just leave it as is. If you do end up with a fraction that can be simplified, so like for example 4 over 8, which would give you 1/2, or 10 divided by 2, which gives you 5, or if you had a negative on the top and a negative on the bottom, two negatives would cancel out to give you a positive answer. I will be expecting you guys to simplify your fractions as much as possible. All right, number 13, calculate the slope of the line that passes through the following 2 points. So when you're given 2 points like that, we can't really count how many boxes or units because we don't have a graph. We're going to have to use a slope formula. The slope formula is going to be y2 minus y1 over x2 minus x1. Okay, there's 4 values there. So going from left to right, 9, 8 is the first point we see. So we're going to label that x1, y1. 5, 1 is the second point we see. So we're going to label that x2, y2. Okay. Sometimes what I recommend students, put the minus signs right away, because if there's double negatives, we're not going to catch that sometimes. All right, so let's plug things in. y2 is 1 minus y1, which is 8. X2 is 5 minus x1, which was 9. Okay, in your numerator, 1 minus 8 gives us a -7. Your denominator, 5 minus 9, gives you a -4. And then 7 over 4 can't be simplified any further, but a negative divided by negative will end up giving us a +7/4. So our slope, our final answer, is going to be slope m equals a +7/4. Okay, rate of change is just another way of saying slope. So they want you to calculate slope, but they want you to take into consideration the 2 variables that we're talking about here: time measured in hours and distance measured in miles. Okay, when you have a table, the row on top is your x, or let's say you had a table going up and down like a vertical one. The column to the left will be your input, your x, and the one on the right would be your y, or in this case, the one on the bottom would be your y. Okay, so slope equals change in y over the change in x. Okay, so I'll show you a couple different ways to do this, and whatever problem you see on the test, you can sort of decide which method you like. So change in y, we want to go from left to right. So how do we go from 7 to 10, 10 to 13? Using the same pattern, it looks like it's going up by 3, and we're talking about miles, so that's +3 miles. Change in x, how do we go from 1 to 1.5 to 2? It looks like we're going up by 0.5, and we're talking about hours. And then what you're going to want to do is take the numerator divided by the denominator. So in your calculator, 3 divided by 0.5 is going to end up giving you 6. Okay. Let's write that as a fraction, put it over 1. The numerator was talking about miles. The denominator was talking about hours. So in a sentence, what's going on here? Basically, Jessica runs 6 miles per hour. Number 15. Decide whether each statement about the graph is true or false and circle your answers. First statement says the slope is 0. If we had a slope that was 0, we would have a line that's completely horizontal. This line is not completely horizontal. It's more a diagonal. It looks like it's decreasing. So this one would be false. The next one says 0, 2 is the x-intercept. So 0, 2, that gives us an x value of 0, y value of 2. So we start at the origin, we go up to, this is the point 0, 2. Now, it is an intercept, but it's not an x-intercept. It's a y-intercept. So this is a false statement. The next one says 3, 0. So that's the x value 3, the y value 0. 1, 2, 3 to the right, 0. That is an intercept, but it's not a y-intercept. So that's false. Be very careful. Make sure you look at the details, because if not, I could see how someone could easily have marked those as true. The next one, the rule is y equals 2/3 x plus 2. Let's see, 2 would represent my y-intercept. On the y-axis, we have a point at 2. That looks okay. They're saying that the slope is 2 over 3. We have to go down 2, so that would make it negative, and to the right 3, that would be positive. So that one's going to be false. It did have the right y-intercept, but the wrong slope, right? Another clue, the slope 2/3, it's positive, yet we have a line that's going downwards. It's decreasing. So that should have been our immediate red flag that something in that equation was wrong. All right, f of 1 is equal to 1. This is telling you f of x is equal to y. So they're telling you that when the x value is 1, the y value is 1. So we're looking to see if that point is really on the line. So 1, 1 would be here. It's really close, but it's not on the line, so that's actually false. Okay, same thing here. Now they're telling us that the x is 3 and the y is 0. So let's see if the point 3, 0 exists. 1, 2, 3, 0. Sure enough, it is on the line, so that is a true statement. And then the last one's telling you that the slope is 3 over 2, but we calculated before, and the slope is actually negative 2/3. So this is false as well. Okay. Notice for this example, all of them except one were true. That won't always be the case. Please don't make any assumptions as to how many true statements there will be and how many false statements. Look at each one individually. I strongly recommend calculate the slope, calculate the y-intercept of your line, so that you don't make a silly mistake by not paying enough attention.